There we are, Flang update. How y'all doing? What's the news? Well, we were started a long time ago. It was NSA and the Department of Energy that kicked it off, and we were the third Flang or the fourth Flang. And we upstreamed and became an official project in 2019, and it's been quite a number of years since then. So what's fresh? The Flang driver, which was for years not built, and then it was called Flang New for a long time because we didn't really want people to use it when it wasn't ready. Just last week or the week before, we renamed it to Flang. So in LLVM 20, there's going to be a Clang and a Flang. So there'll be a first-class Fortran compiler for CPU, and it's working really well. And last 3 months, 262 commits by NVIDIA contributors. We're still pretty much the main contributors, but less than half now, which is really good. 272 by 67 other people all over the place. AMD, IBM, ARM, lots of companies. Test suites, big thanks to Fujitsu and IBM for open sourcing their huge test suites. So these are great 2003, Fortran 2003 tests, 30,000 tests or something like that. That's really fantastic of them to do that. It was a big process for them to go through the legal and then the engineering reviews of all that to get that for all of us. And in the debugging note, there is extensions for Dwarf that are for Fortran, all the different kinds of arrays that you get with Fortran. And that support is being updated right now. Just because we're talking about debuggers today, I thought I'd just throw that in too. Performance, people don't write Fortran to run slow. They don't really want it to run a program because it's a great programming language for just general purpose stuff. They want to run loops and they want to run them fast. So this is comparing to GFortran. Lower is better because it's in seconds, and it's a benchmark suite called Polyhedron, which is pretty common, sort of a basic beginner suite. And we're just running Flang, MLIR to LLVM with not a lot of optimization. So we've gone through and inlined a bunch of intrinsics, and we're trying to get temp elimination. We're trying to do provide the information that the vectorizer needs to do its job. And you can see we're getting pretty close there. The geomean is the interesting number. The geomean is the interesting number, and they're pretty close. You see a couple of outliers. Most of those outliers are probably parameters that are being duplicated when they're passed because we just haven't done the alias analysis yet. There's a big alias analysis for FIR, which is our MLIR intermediate that was upstreamed last week or the week before. And 2 weeks ago was a big time for us. So what are we looking at doing for the next year? More CPU performance improvements, right? We have GFortran's a good base, but then the commercial compilers are even better. And we want to be able to use more MLIR. We want to be able to use more of what LLVM has, mostly in loop optimizations and vectorization, but also to eliminate the extra copies that we have. A lot of intrinsic routines to do reductions, to do sine and cosine, things like that need to be specially handled and to get up with those commercial compilers. OpenMP for multi-core. Almost every Fortran program does some sort of multi-core processing. That's being done by ARM mostly and a lot of other contributors. That's progressing really well. They're getting to where they can run lots of programs, and they're trying to make it a little more user-friendly, so things that aren't implemented will show as not implemented. Taking OpenMP and offloading it to a GPU, that's using a lot of the standard support that's in upstream right now for Clang, and it's starting to run programs pretty well too. Sometimes they run really fast. Sometimes the optimization is not quite there. They're still a work in progress, but good. CUDA Fortran, which is like CUDA, but in Fortran, you can write kernels, you can do all sorts of things and runs on the device. That's being upstreamed right now, and then we're following that up with OpenACC, which is another way to write programs for accelerators. And one more. We have Discourse channel, we have source code, where you all know where that is. We have a project call every week. Mondays and Wednesdays alternate. Sometimes it's project business, sometimes it's technical business. Usually they overlap. All that information you can find on the llvm.org website. And that's it for Flang.
Thank you, Steve.